In this class, we are going to learn how to differentiate an implicit function.
In our previous class, we've learned how to find the derivative of an explicit function, which is quite easy to do.
A typical example is this: y equals to 2x plus 4x squared. It is easy to differentiate this kind of function. The derivative of y will be equals to 2 plus 8x. But let's consider the question that we have on the board. Xy plus x squared y equals to 0. How do we find the derivative of this function? This kind of function that you see on the board is called implicit function. Are you getting it? And in this function, we are going to be differentiating y. We are going to be differentiating y with respect to x. Do you understand? We are looking for the derivative of y with respect to x. In that case, that means that y is an implicit function of x. Okay, to take the derivative of this function, please kindly note that anytime you differentiate y in this function, you're going to multiply the derivative of y with by dy dx. Are you getting it? It is simple. Anytime you differentiate y in this function, you are going to multiply that derivative by dy dx. And the reason is simply because we are differentiating y with respect to x. Do you get it? Okay, so now let's start. This function, let's start with this. We have xy. Xy simply means x multiplied by y. And I told you in our previous class that anytime you want to differentiate a function that has product, you're going to engage product rule. You understand? So let us use product rule to differentiate xy. The first step is that you have to keep the first part of the function, you have to keep it constant. The first part of this function is what? X. So I'm going to keep x constant. I'm going to differentiate y. If you differentiate y, you're going to have 1, right? So I'm going to have this multiplied by 1. And anytime you differentiate y, you're going to multiply that derivative by dy dx. So I'm going to have times dy over dx. Are you getting it? Plus, now, you're going to keep the second part of the function, which is y. You're going to keep it constant. So I'm going to have y multiplied by the derivative of the first part. The derivative of the first part is what? X. So I'm going to have y times derivative of x. Derivative of x is 1. So I'm going to have y times 1. Okay? So I'm done with the derivative of this. Now, let us differentiate x squared y as well using product rule. Please kindly pay attention. It's simple. Just put plus. Now, you're going to keep the first part. You're going to keep it constant. I'm going to have x squared. Then you're going to differentiate y. If you differentiate y, you're going to have 1. And I told you that because we are differentiating y with respect to x, anytime you differentiate y in this function, you're going to multiply that derivative by dy dx. So I'm going to have x squared multiplied by 1 times dy over dx. Okay? Now, put plus. You're going to keep y. You're going to keep it constant. So I'm going to have y. Differentiate x squared. You're going to have what? 2x. Okay? So all this will be equals to 0. Okay? Now, x times 1 times dy dx, that is what? X dy all over dx plus y, okay, plus x squared times 1 times dy dx, that is what? X squared dy all over dx plus 2xy equals to what? Equals to 0. Do you understand? Okay. Now you can just remove the bracket and then you can solve. Having gotten to this point, the next step is that you have to collect like terms. The term that has dy dx, for example, this term and this term, you have to bring them together. So I'm going to have x dy all over dx plus x squared dy all over dx. Okay. I'm going to take this 2xy, I'm going to take it to the right hand side of the equation. It's going to become negative 2xy. So I'm going to have negative 2xy. Now, what of this y? If you take this y to the right hand side of the equation, you're going to have what? Negative y. So, having gotten to this point, the next step is that you have to factorize dy dx. You understand? So, because dy dx is common to this and this, I'm going to have dy all over dx multiplied by x plus x squared, okay, equals to negative 2xy minus y. Do you understand? Okay, dy all over dx will be equals to, now divide both sides of the equation by x plus x squared. So I'm going to have negative 2xy minus y all over x plus x squared, okay, which is the final answer to the derivative of xy plus x squared y. You can see that it's simple. Listen, if you want to take the derivative of the implicit function, whatever you are differentiating, you have to multiply that derivative by dy all over the x. You understand? Okay. Let's look at more work example here. Let's say you are given this function x squared plus y squared plus 2xy equals to 0, and you are asked to find the derivative of this function with respect to x. Okay, that is, you are differentiating y with respect to x. Now let's start with this. Now you can see that the sign between x squared and y squared is what? Is a plus sign. So here we cannot make use of product rule. Just differentiate it term by term. You understand? Differentiate the function individually. So if you differentiate x squared, you're going to have what? 2x. So I'm going to have 2x plus. Now if you differentiate y squared, you're going to have 2y. Okay, so I'm going to have 2y here. Now I told you that anytime you differentiate y, you're going to multiply that derivative by dy dx. Don't forget. So I'm going to have this multiplied by dy all over the x plus. Okay, now we want to differentiate 2xy. The sign between 2x and y is what? Is a product sign, because that is 2 times x times y. Okay, open a big bracket. Put these two, put it outside. Okay, open a big bracket. Now differentiate x and y. Okay, it's simple. Just pay attention. It is easy to differentiate x squared because x squared is not attached to anything, right? It is also easy to differentiate y squared because y squared is not attached to anything. Okay, now but here we have 2xy. Take this number, take it outside, open a big bracket, differentiate xy using the product rule. Okay, now according to product rule, you have to first keep the x, you have to keep it constant, or you can do it the other way, just like we did for this one. You keep the x, you keep it constant. So I'm going to have x multiplied by the derivative of y. Derivative of y is what? 1. And I told you that anytime you differentiate y, you're going to multiply that derivative by dy over the x. And the simple reason is because it is y that we are differentiating with respect to x. Do you understand? So for this, I'm going to have x times dy over the x, because if you differentiate y, you're going to have 1. And 1 times dy dx is still dy dx. So I'm going to have x times dy over the x. Then you're going to put the addition sign. Okay, now you're going to keep the second part, or you're going to keep y, you're going to keep it constant. I'm going to have y, differentiate x, you're going to have 1. So I'm going to have y times 1. Y times 1 is what? Y. So I'm going to have y. All this will be equal to what? 0. Do you understand? Okay, don't worry if you don't understand, just follow me to the end of this class. Okay, you're going to understand at the end of this class. Now, having gotten to this point, I'm going to have 2x plus 2y dy all over the x plus 2x dy over the x plus 2y. Do you know what I did? I just opened this and I multiply these two by everything that I have here. Do you understand? So that's how I got this. 2 times this will give me this, and 2 times y will give me 2y. This will be equals to 0. Okay. Now the next step is that you have to collect like terms. That is, the terms that are similar to each other, bring them closer to each other. For this 2y dy dx, I'm going to have 2y dy over the x plus 2x dy all over the x equals to, now this 2x take to the right hand side of the equation. I'm going to have negative 2x, and then what of this 2y? Take it to the right hand side of the equation. I'm going to have negative 2y. Okay, so the next step is that you have to factorize dy dx. So I'm going to have dy all over the x multiplied by 2y plus 2x equals to negative 2x negative 2y. Okay, the next step is that you have to divide both sides by 2y plus 2x all over 2y plus 2x. Okay, dy all over the x is equals to negative 2x minus 2y all over 2y plus 2x. Okay, now from this point you can factorize 2. So I'm going to have here dy all over the x is equals to 2 multiplied by minus x minus y. Okay, this all over, please pay attention, 2 multiplied by y plus x. And you can also factorize You can factorize negative 2. You understand? That is, here you're going to have negative 2 multiplied by x plus y. Okay? Are you getting it? You can factorize like this. Negative 2 multiplied by x plus y. So for this, I'm going to have dy all over dx is equals to negative 1. Do you know how I got this? X plus y is also the same thing as y plus x. Are you getting it? So this will cancel this. Do you understand? So negative 2 over 2 will give me what? Negative 1. So dy dx is negative 1. Now, let's say you are given this question, xy equals to 0, and you are asked to differentiate it. How do you go about it? Well, to do this, it's simple. Don't forget that we are differentiating y with respect to x. Are you getting it? And anytime you differentiate y, you're going to multiply that derivative by dy dx. Do you get it? Now, I'm going to use product rule to differentiate xy because the sign between x and y is a product sign. Do you get it? So for this, keep x constant, x, differentiate y, you're going to have 1. And anytime you differentiate y, you are multiplying that derivative by dy over dx. Do you get it? So for this, I'm going to have multiply by dy over dx plus, now keep y constant, differentiate x. I'm going to have y times 1. If you differentiate x, you're going to have 1. 1 times y is what? Y. So this will be equal to what? 0, okay? Now for this, I'm going to have x dy over dx is equals to negative y, okay? All over x, this all over x, dy all over dx is equals to negative y all over x, which is the final answer. Do you understand? Okay, so we are still going to go over more questions on implicit function. Are you getting it? So just pay attention and make sure you watch this class till the very end. Okay, let's consider the question that we have on the board. We are asked to find the derivative of the function with respect to x. That is, we are asked to differentiate y with respect to x. In finding the derivative of an implicit function, anytime you differentiate y in this function, you are going to multiply the derivative of y with respect to x. Are you getting it? That is the rule. Whenever you differentiate y in this function, you are going to multiply that derivative by dy all over dx. Do you get it? And the simple reason is because it is y that we are differentiating with respect to x. Do you get it? Okay, now let's start with this. We have xy equals to 1. To find the derivative of this function, because the sign between x and y is a product sign, so we're going to make use of the product rule of differential calculus. Do you understand? So according to product rule of differential calculus, we're going to keep the first part, we're going to keep it constant, which is x. Then we're going to differentiate y. If you find the derivative of y, you're going to have 1. And because I told you, whenever you differentiate y in this function, you're going to multiply that derivative by dy dx. So I'm going to have 1 times dy dx. So I'm going to have, that is dy over dx. Are you getting it? Plus, now keep the second part, keep y constant, differentiate x, you're going to have 1. So 1 times y is what? Y. This will be equals to 0, because if you differentiate 1, you're going to have 0. If you didn't understand, listen again. To differentiate this function, we are going to use product rule. According to product rule of differential calculus, I'm going to keep the first part, which is x, I'm going to keep it constant, and I'm going to differentiate y. Whenever you differentiate y in this function, you're going to have you're going to multiply that derivative by dy dx. Are you getting it? Now differentiate y, you're going to have 1, right? And because you are going to multiply that 1, you're going to multiply it by dy dx. 1 times dy dx is what? Dy dx. So multiply that dy dx by x, you're going to have this. Now you're going to keep the second part, which is y, you're going to keep it constant and differentiate x. If you differentiate x, you're going to have 1. 1 times y is what? Y. And if you differentiate 1, you're going to have 0. So I'm going to have 0 here. Do you get it? Okay, now let us proceed. The goal is to find dy dx. So I'm going to take x, okay, x dy over dx is equals to, now take this y to the right hand side. I'm going to have negative y. So divide both by x, this over x, dy all over dx is equals to negative y all over x, which is the final answer. Okay, what of this? We have x cubed plus y cubed equals to 2. How do we find the derivative of this function? Well, we are still going to progress the same way. Anytime you differentiate y in this function, you are going to multiply that derivative by dy dx. Do you understand? okay, because it is y that we are differentiating with respect to x, as you can see. So for this, differentiate x cubed, you're going to have 2x squared. Oh, sorry, 3x squared. 3x squared. Now, if you differentiate y cubed, you're going to have what? 3y squared. And I told you, whenever you differentiate y, you're going to multiply that derivative by dy over dx. Do not forget. So I'm going to have multiply by dy over dx equals to, if you differentiate 2, you're going to have 0. So for this, I'm going to have 3y squared dy all over dx is equals to negative 3x squared, okay? To get the value of dy dx, we divide both sides by the coefficient of dy dx, which is what? 3y squared. So this over 3y squared and this over 3y squared. I'm going to have dy all over dx is equals to negative 3x squared all over 3y squared, okay? Now this will cancel this. So I'm left with what? Dy all over dx is equals to negative x squared all over y squared, okay? Which is the final answer. I hope you understand. Okay, what of this? We have x squared y squared minus 6xy plus 3xy squared equals to 2. We are asked to find the derivative of this. Well, to do this, please pay attention. Let's start with this. Looking at this, you will discover that the sign between x squared and y squared is what? Is a product sign. And I've told you that in our previous class that whenever you have a function that has two parts, and these two parts are multiplying each other, you make use of the product rule to differentiate such function, okay? So let's do this using product rule. The first step is that you have to keep x squared, you have to keep it constant. So I'm going to have x squared, then differentiate y squared. You're going to have what? 2y. And I told you, because it is y that you are differentiating with respect to x, whenever you differentiate y in this function, you're going to multiply that derivative by dy over dx. Do you understand? So for this, I'm going to have 2y multiplied by dy over dx, okay? Now, the next step is that you have to keep y squared, you have to keep it constant, y squared, then you have to differentiate x squared. Derivative of x squared will be what? 2x, okay? So we are done with that. Put it inside the bracket. Minus, now listen to me carefully. We have negative 6xy. If you want to differentiate negative 6xy, put that negative 6, put it like this, then differentiate xy. If you differentiate xy, what are you going to have? You're going to have x dy over dx plus y. Just like what we did here. Are you getting it? And then now we move to the third part, which is plus 3xy squared. Okay? This plus 3, put it like this, plus 3, then differentiate xy squared. If you keep first part, you keep it constant. Differentiate y squared, you're going to have 2y. Then whenever you differentiate y, you're going to multiply that derivative by dy dx. So I'm going to have 2y dy all over dx plus, now you have to keep y squared, you have to keep it constant. I'm going to have y squared, differentiate x, you're going to have what? 1, abi? So I'm going to have multiply by 1. Y squared times 1 is what? Y squared. So I'm going to have this. This will be equals to 0, because if you differentiate 2, you're going to have 0. Do you understand? Okay. For this, I'm going to have 2x squared y dy all over dx plus 2xy squared minus 6x dy all over dx minus 6y plus 3x plus, sorry, plus 3 times 2 plus 3 times x2y, that is what? Plus 6xy dy over dx plus 3y squared equals to 0, okay? So now the next step here is that you have to collect like terms, that is, bring the term that is attached to dy dx, bring it closer to the bring them closer to others. Are you getting it? The term that is attached to dy dx, bring them and separate them to one part. You understand? So I'm going to have 2x squared y dy over dx minus 6x dy all over dx plus 6xy dy all over dx. Okay, I'm done with that. Then I'm going to have plus 2xy squared, okay, minus 6y plus 3y squared equals to what? 0. What I did was that the term, or the term that that is attached to dy dx, I separate them. Do you understand? And the reason is because I want to factorize out dy dx. Just pay attention, okay? For this now, I'm going to have 2x squared y dy all over the x minus 6x dy all over the x plus 6xy dy all over the x is equals to, now all these, take them to the right hand side of the equation. You're going to have 3y squared plus 2xy squared minus 6y. Are you getting it? Okay, now this will be negative, this will be negative, this will also be negative, also this will be positive. You understand? Because if this plus 2xy squared crosses to the other side, you're going to have negative, and if this also crosses to the other side, you're going to have negative. Are you getting it? Then because 6y is negative before, if it cross the equals to sign, you're going to have positive. Do you understand? So for this, now factorize dy dx. I'm going to have dy all over the x, 2x squared y minus 6x plus 6xy is equals to minus 3y squared minus 2xy squared plus 6y. Okay, now having got it to this point, to get the value of dy dx, I'm going to divide both sides by 2x squared y. I'm going to divide both sides by this 2x squared y minus 6x plus 6xy, and this also over 2x squared y minus 6x plus 6xy. Okay, hence dy all over the x is equals to negative 3y squared minus 2x y squared plus 6y. All this all over 2x squared y minus 6x plus 6xy. Okay, so that is the value of dy dx. Okay, you can see that it's simple. What matters is understanding. Okay, what matters is understanding. Okay, now anytime you encounter this kind of question, the first thing to check is that check what you are differentiating, and also check what you are differentiating with respect to. Are you getting it? If you look at the question, we are asked to differentiate y with respect to x. So anytime we differentiate y in that function, we multiply that derivative by dy dx. Assuming we are asked to differentiate x with respect to y, anytime you differentiate x, you're going to multiply that derivative by dx over dy. Do you understand? So it is simple. Just follow the step, and you're going to obtain a good answer. So if you come across this in your exam, make sure you undo it very well. Okay. Now let's go over more question on implicit differentiation. Okay. Okay. Let's consider the question that we have on the board on implicit differentiation. Here we are asked to find the derivative of this function with respect to x. That is, we are differentiating we are differentiating y with respect to x. Okay, let's start with this. We have x raised to the power of 4 plus y raised to the power of 4 equals to 28xy. How do we take the derivative of this function? Let's rewrite this function as this: x raised to the power of 4 plus y raised to the power of 4 minus 28xy equals to 0. Okay, now let us differentiate x raised to the power of 4. Differentiating x raised to the power of 4, we're going to have 4x raised to the power of 3. Okay, let us differentiate y raised to the power of 4. If you differentiate y raised to the power of 4, you're going to have 4y raised to the power of 3. Now, because it is y that we are differentiating with respect to x, anytime we differentiate y in this function, we're going to multiply that derivative by dy all over the x. Okay, for this, I'm going to have multiplied by dy all over the x. Okay, now let's proceed to the last part of this function, negative 28xy. To differentiate negative 28xy, please pay attention. Put negative 28 like this, then open a big bracket. Differentiate xy using product rule. If you want to differentiate xy using product rule, you first have to keep keep it constant. Differentiate y. If you differentiate y, you're going to have what? 1, right? Now, that 1 multiplied by dy dx, that is what? Dy dx. So I'm going to have x multiplied by dy all over the x. Okay? Then as the addition sign, keep dy, keep it constant, differentiate x. If you differentiate x, we're going to have 1. So I'm going to have y times 1. Y times 1 is 1. Y times 1 is y. So I'm going to have this equals to what? 0. Okay, for this, I'm going to have 4x raised to the power of 3 plus 4y raised to the power of 3 dy all over dx minus 28x dy all over dx minus 28y equals to 0. Are you there? Now, having gotten to this point, the next step is that collect like terms. Are you getting it? Separate the term that is attached to dy dx. Separate them. So for this, I'm going to have 4y raised to the power of 3 dy all over dx minus 28x dy all over dx equals to, now this 4x to the power of 3, take it to the right hand side, is going to become negative 4x to the power of 3. Also, this negative 28y, take it to the right hand side, I'm going to have negative 28y or positive 28y because the sign is going to change. Okay, having gotten to this point, factorize dy dx. I'm going to have dy over dx multiplied by 4y to the power of 3 minus 28x equals to negative 4x raised to the power of 3 plus 28y. Okay, now divide both sides by 4y cube, 4y cube minus 28x. I'm going to have dy over dx is equals to negative 4x raised to the power of 3 plus 28y all over 4y raised to the power of 3 minus 28x. Okay, for this, I'm going to have dy all over dx is equals to 4 multiplied by negative x raised to the power of 3, are you there, plus 7y all over 4 multiplied by 4, okay, y raised to the power of 3 minus 7, okay, minus 7x, okay. So dy all over dx will be equals to negative x to the power of 3 plus 7y, all this over y raised to the power of 3 minus 7x, okay. That is the final answer. Do you understand? If you didn't understand, kindly listen to the explanation again, okay? It's simple. When you get to there, you see, your ability to factorize is very important here, okay? You know that 4 is common to both this term and this term. 4 times negative x raised to the power of 3 is to give me negative 4x raised to the power of 3. 4 times this will give me this. So I just cut out this 4. So I'm left with this, okay? So that is the solution to this question. Now let's look at this. We have x squared plus y squared plus xy equals to 3. We are asked to find the derivative. Let us start with this x squared. If you differentiate x squared, what are you going to have? 2x, right? I'm going to have 2x. Then if you differentiate y squared, you're going to have what? 2y. And then multiply by what? dy over dx, okay? Plus, now, differentiate xy. What are you going to have? You're going to have x dy over dx plus y equals to 0, because if you differentiate 3, you're going to have 0. Are you getting it? Okay, now the next step is that you have to separate the term that is attached to dy dx. Do you understand? So for this, I'm going to have 2y dy over dx plus x dy over dx equals to negative 2x negative y. Okay, now factorize. I'm going to have dy over dx multiplied by 2y plus x equals to negative 2x negative y. To get the value of dy dx, what do? Divide both sides by 2y plus x. So dy over dx is equals to negative 2x minus y all over 2y plus x, which is the final answer. Okay, now let's consider this question also. How do we find the derivative of this function implicitly? Well, to do this, let's start with this. Differentiate x squared y squared using product rule. You are going to have 2x, okay, let's keep x constant, x squared multiplied by 2y dy all over dx plus y squared multiplied by 2x. Do you understand? According to product rule, keep x squared constant, differentiate y squared. Keep y squared constant, differentiate x squared. Are you getting it? So now differentiate negative x, you're going to have what? Negative 1. Differentiate negative y, you're going to have what? Negative 1. And then now you're going to multiply that derivative by dy dx. Are you getting it? As stated earlier. Do you understand? So for this, I'm going to have negative 1 times dy dx. That is what? Negative dy over dx equals to what? 0. Okay, now the next step is that you have to separate the term those terms that is attached to dy dx, you have to separate them. So for this, I'm going to have 2x squared y dy over dx minus dy all over dx equals to, now take this to this other side. I'm going to have 2xy squared plus 1. Okay, having gotten to this point, the next step is that you have to factorize dy dx. So I'm going to have dy all over dx multiplied by 2x squared y minus 1 equals to 2x y squared plus 1. To get the value of dy dx, you divide both sides by what? 2x squared y minus 1. So I'm going to have dy all over dx equals to 2x y squared plus 1 whole over 2x squared y minus 1. Okay, you can see that it's simple. Hello, you can see that it's simple. So you can leave your answer like this. That is the solution to that question. If you didn't understand, just let me reiterate. Okay, listen. Anytime you are differentiating an implicit function, notice what you are differentiating and notice what you are differentiating with respect to. Are you get what I'm trying to say? We are differentiating y with respect to x. So anytime we differentiate y in this function, we're going to multiply the derivative by dy dx. You understand? And to differentiate x squared, y squared, you use product rule because the sign between x squared and y squared now is a product sign. Are you getting it? And if you engage product rule to differentiate this, you're going to have this. Differentiate negative x, you're going to have negative 1. Differentiate negative y, you're going to have negative 1, right? Now, because we are differentiating y with respect to x, you are going to multiply that negative 1 by dy dx. Negative 1 times dy dx will give me negative dy dx. Are you getting it? So that's why I have this. Then I collect like terms and then I factorize. Then I arrive at this answer. Okay. So that is the solution to that question. Let's consider more question on implicit differentiation. Okay. Let's consider the question that we have on the board. We are asked to differentiate this function implicitly. Okay. To differentiate this function with respect to x, that is, we are asked to find the derivative of y with respect to x. Let's start with this. Differentiate x squared. What are you going to have? You're going to have 2x, right? So I'm going to have 2x here plus, now we want to differentiate 6xy. Put 6 here, differentiate xy. You're going to have x dy all over dx plus y. Okay. If you want to differentiate 5y squared, what are you going to have? You're going to have plus 10y multiplied by dy all over dx. This will equals to 0. Do you understand? Okay. For this, I'm going to have 2x plus 6x dy all over dx plus 6y equals to O plus 10y dy all over dx. This will be equals to 0. Now, the next step is that you have to separate the term that is attached to dy dx. So I'm going to have 6x dy all over dx plus 10y dy all over dx. Okay, this 2x and this plus 6y, take it to the left to the right hand side of this equation. I'm going to have negative 2x negative 6y. Okay, having got it to this point, the next step is that you have to factorize dy dx. So I'm going to have dy all over dx multiplied by 6x plus 10y equals to negative 2x negative 6y. Okay, divide both sides by 6x plus 10y. So I'm going to have dy all over dx is equals to negative 2x negative 6y whole over 6x plus 10y. Okay, now having gotten to this point, you can factorize 2. You understand? You can factorize 2. So I'm going to have dy all over dx is equals to 2 multiplied by, okay, let's go. I'm going to have negative x minus 3y. Okay, and this all over 2 multiplied by 3x plus 5y. Okay, so I'm going to have dy all over dx will be equals to negative x plus 3y all over 3x plus 5y, which is the final answer to that question. Okay, you can see that finding the derivative of an implicit function is quite simple. All you have to do is just follow the steps. Are you getting it? Okay, so the derivative of this function is this. If you didn't understand, let me reiterate. If you differentiate x, so you're going to have 2x. Now, to differentiate 6xy, the product between x and y is a product sign. The sign between x and y is a product. So And if you have a product of two functions, you use product rule of differential calculus. Okay, if you differentiate this using product rule, you are going to have this, right? And if you differentiate 5y squared, you're going to have 10y. And because it is y that we are differentiating with respect to x, you're going to, anytime you find derivative of y, you're going to multiply that derivative by dy over dx, and then you simplify. Okay, now let's do this. We have, find the derivative of x raised to the power of 4 plus 5x squared y squared plus 4x squared plus 3y squared equals to 10 with respect to x. Okay, how do we differentiate this? Let's start with this. Differentiate x to the power of 4. What are you going to have? 4x raised to the power of 3, right? Plus 5, open the bracket. Differentiate x squared. You're going to have what? Okay, keep x squared constant. You know that here now you're going to use product rule. You understand? So keep x squared, keep it constant. Differentiate y squared. You're going to have what? 2y dy over dx plus, now keep y squared, keep it constant. I'm going to have y squared. Differentiate x squared. You're going to have 2x, right? Then put the plus sign. Differentiate 4x squared. You're going to have 8x. Then differentiate 3y squared. You're going to have what? Plus 6y dy all over dx equals to what? 0. Because if you differentiate 10, you're going to have 0. Derivative of a constant is 0. Do you understand what I did? I've not done anything. This 5 here is here. Then I use product rule to differentiate x squared, y squared. Then I got this, okay? For this, I'm going to have 4x raised to the power of 3 plus 5x, okay? 5 times x squared, 2y. 5 times 2 is what? 10. So I'm going to have 10 x squared y dy over dx. 5 times y squared is 2x. That is what? Plus 10x y squared plus 8x plus 6y dy over dx equals to what? 0. Now, having gotten to this point, the next step is that you have to separate the term that is attached to dy dx. Are you getting it? Separate the term that is attached to dy dx. So I'm going to have 10x squared y dy over dx plus 6y dy over dx, because now 10x squared y is attached to dy dx, and also dy dx is attached to 6y. So I bring them together. Are you getting it? Now this will be equals to, now take this 4x raised to the power of 3, take it to the right hand side. I'm going to have negative 4x to the power of 3. Now take this plus 8x minus 8x. What of this? Plus 10xy squared. Do you understand? Negative 4x squared to the power of 3, negative 10x raised to the power of 2, and then negative, oh, it's not plus, oh, it's supposed to be minus. Are you getting it? Now factorize dy dx. I'm going to have dy all over dx multiplied by 10x squared y plus 6y equals to minus 4x raised to the power 3 minus 8x minus 10x y squared. Okay, having got it to this point, the next step is to divide both sides by 10x squared y plus 6y. dy all over dx will be equals to negative 4x raised to the power of 3 minus 8x minus 10x y squared, all this all over 10x raised to the power of 2y plus 6y. Okay, so if you wish to factorize 2, you can factorize. Okay, dy all over dx will be equals to 2 multiplied by negative 2x raised to the power 3 minus 4x minus 5xy squared, this all over 2 multiplied by 10, 2 multiplied by 5x squared y plus 3y. Okay, so dy all over dx will be equals to negative 2x raised to the power of 3 minus 4x minus 5x y raised to the power of 2, this all over 5x squared y plus 3y. Okay, so the end product of the derivative of this function is this. Do you understand? Okay, now let's look at this question. We are asked to find the derivative of x raised to the power of half plus y raised to the power of half equals to 1 with respect to x. We are differentiating y with respect to x. Okay, to solve this question, we are still going to go the same way. Take the derivative of x raised to the power of half. I'm going to have x Okay, 1 over 2x raised to the power of what? Negative 1 over 2. Do you know? Plus, now take the derivative of y raised to the power of half. You're going to have 1 over 2y raised to the power of negative 1 over 2. Now, because it is y that we are differentiating with respect to x, anytime you take the derivative of y in this function, you're going to multiply that derivative by derivative of y and x. So I'm going to have this times dy all over the x. And then if you differentiate 1 is a constant, so you're going to have 0. This will be equal to what? 0. Okay, for this I'm going to have 1 over 2 root x, 1 over 2 root x plus 1 over 2 root y multiplied by dy over dx equals to 0. Okay, 1 over 2 root y dy all over dx will be equals to negative 1 all over 2 root x. Do you understand? Because I just take this 1 over 2 root x to the right hand side of the equation, so it becomes negative. Are you getting it? Now, having gotten to this point, the next step is to divide both sides by 1 over 2 root y so that I can get the value of dy over dx. So for this, I'm going to have dy all over dx is equals to negative 1 over 2 root x divided by 1 over 2 root y. Okay, dy all over dx will be equals to negative 1 over 2 root x multiplied by 2 root y all over 1. Okay, 2 root y times negative 1. What are you going to have? Negative 2 root y. Then 2 root x times 1. What are you going to have? That is what? 2 root x. Put dy dx. So dy all over dx will be equals to this. We cancel this. Are you getting it? So I'm left with what? Negative root y all over root. Oh, sorry. This should be root x. Oh, sorry. Root x, root x. Do you understand? And if you want to put it like this, you can put it like this: dy all over dx is equals to negative square root of x and y all over x. Do you understand? Okay, so you can see that finding the derivative of an implicit function is simple. Okay, let's look at more work example. Okay, let's consider the question that we have on the board on implicit differentiation. We are asked to find the derivative of this function with respect to x. Okay, let's start with this. In differentiating this function with respect to x, the first step is that let us expand what we have here. I'm going to have x squared minus y squared multiplied by x squared minus y squared equals to 7. Okay, now expand. X squared times x squared, that is what? X to the power of 4. X squared times negative y squared, that is negative x squared y squared. Negative y squared times x squared, we're going to have negative x squared y squared. Negative y squared times negative y squared, that is what? Positive y raised to the power of 4 equals to 7. Okay, for this, I'm going to have x raised to the power of 4 minus 2x raised to the power of 2, y raised to the power of 2, plus y raised to the power of 4 equals to 7. Do you understand? I've not done anything. I'm just expand. And I just expand the bracket. You understand? So for this now, we can differentiate. If you want to differentiate y with respect to x, let us differentiate x raised to the power of 4. I'm going to have 4x raised to the power of 3. Differentiate negative x squared y squared. You're going to have negative 2. Now, we are going to use the product rule to differentiate x squared y squared. Keep x squared constant. Differentiate y squared. You're going to have 2y. And because it is y that you are differentiating with respect to x, anytime you differentiate y, you're going to multiply that derivative by dy dx. So I'm going to have 2y multiplied by dy over dx. Plus, now, keep y squared. Keep it constant. I'm going to have y squared. Differentiate x squared. You're going to have what? 2x. Are you getting it? Okay, plus now let us differentiate y raised to the power of 4. Derivative of y raised to the power of 4 will be 4y raised to the power of 3. And then because we are differentiating y with respect to s, this will also be attached with dy all over the x, because now we differentiate y. Now, if you differentiate 7, you're going to have 0. So for this, I'm going to have 4x to the power of 3 minus 4x raised to the power of 4y dy all over dx plus 4xy squared. Okay, It's supposed to be minus. Minus 2 times this. That will be what? Minus, okay, minus 4x y raised to the power of 2 plus 4y raised to the power of 3 dy whole over dx equals to 0. Do you understand? Okay, now the next step is that you have to separate the term that is attached to dy over dx. Are you getting it? You have to separate the term that is attached to dy over dx. In this equation, dy over dx is attached to this, dy over dx is attached to this. So I'm going to have negative 4x y raised to the power of, okay, 4x raised to the power of 4. Sorry, I think I make mistake. This should be the power of 2. Negative 2 times 2, that is negative 4. X squared, then y, you put y. So I'm going to have, this supposed to be 2. Negative 4x squared y dy all over dx plus 4y raised to the power of 3 dy all over dx. Are you getting it? Okay. Equals to, now, take this negative 4xy squared, take it to the right hand side. You're going to have 4xy raised to the power of 2. Do you understand? And then take this 4x to the power of 3, take it to the right hand side. You're going to have minus 4x raised to the power of 3. Do you get it? Okay. Having gotten to this point, the next step is to factorize dy dx. So I'm going to have dy all over dx 4y raised to the power of 3 minus 4x squared y equals to 4xy raised to the power of 2 minus 4x raised to the power of 3. Okay, to get dy dx, you have to divide both sides by what? 4y raised to the power of 3 raised to the power of 3 minus 4x raised to the power of 2y is over 4y raised to the power of 3 minus 4x raised to the power of 2y. Okay, so dy all over dx will be equals to 4xy raised to the power of 2 minus 4x to the power of 3. This all over 4y raised to the power of 3 minus 4x raised to the power of 2y. Okay, then you can factorize if you like. Are you getting it? You can factorize 4. I'm going to have dy over dx is equals to 4 multiplied by x raised to the power of, okay, xy squared minus x raised to the power of 3 all over 4 multiplied by y raised to the power of 3 minus 4, okay, minus x squared y. And this 4 will cancel this 4. So therefore, dy all over dx will be equals to xy raised to the power of 2 minus x raised to the power of 3 all over y raised to the power of 3 minus x squared y. Do you understand? So, having gotten to this point, you can still factorize x at the numerator and y at the denominator. So let's do that. For this, I'm going to have dy all over dx is equals to factorize x. I'm going to have x y squared minus x raised to the power of 2. Okay, then at the denominator, I'm going to factorize y. I'm going to have y multiplied by y squared minus x. Y multiplied y squared minus x squared. Do you understand? I just factorize x at the numerator and y at the denominator. So I've not done anything. Now, having gotten to this point, this will cancel this. So I'm going to have dy all over dx equals to x over y, which is the final answer. Do you understand? Okay, let's look at this question that we have on the board. We are asked to find the derivative of y with respect to x in this question. This is an implicit function, and to differentiate an implicit function, you have to take it term by term. In this function, every time you differentiate y, you're going to multiply that derivative by dy over dx. Do you understand? Because it is y that we are differentiating with respect to x. Do you get it? So for this, I'm going to have, let's start with this. The first term here is x cubed y squared. Let us use the product rule to differentiate this term. To use the product rule, keep x raised to the power of 3, keep it constant, differentiate y squared. You're going to have 2y. I'm going to multiply it by dy dx. Now, keep y squared, keep it constant. I'm going to have y squared, differentiate x to the power of 3. I'm going to have 3x squared, right? So we are done with that. Now, the second term is this, y raised to the power of 4, x squared. We are still going to use the product rule to differentiate this. Keep y raised to the power of 4, keep it constant. I'm going to have y raised to the power of 4, differentiate x raised to the power of 2. You're going to have 2x Now keep keep x squared, keep it constant. I'm going to have plus x squared. Differentiate y raised to the power of 4. You're going to have 4y raised to the power of 3 multiplied by dy over dx. Are you getting it? Now let us differentiate the third term. The third term is 3x squared. Differentiating 3x squared, you're going to have plus 6x, right? Then differentiate negative 13x, you're going to have negative 13. And differentiating negative 14, you're going to have 0. So this will be equal to what? 0. Do you understand? Okay, for this, I'm going to have 2yx raised to the power of 3 dy all over dx plus 3x squared y squared plus 2xy raised to the power of 4 plus now 4x squared y raised to the power of 3 dy all over dx plus 6x minus 13 equals to 0. I've not done anything. All I did was that I just simplified. Do you understand? Okay. Having gotten to this point, the next step is that you have to separate the term that is attached to dy dx. You understand? Those terms that is attached to dy dx in this equation, you're going to separate them towards the left hand side. So for this, I'm going to have 2y x raised to the power of 3 dy all over dx plus 4x raised to the power of 2 y raised to the power of 3 dy over dx. This and this is attached to dy dx, so I separated them. This will be equals to now all this, move it to the right hand side of the equation. I'm going to have negative 3x squared y squared plus minus 4x squared y raised to the power of 3 minus 2x y raised to the power of 4 minus 6x plus 13. Okay, so for this, factorize dy dx, dy all over dx multiplied by 2y raised to the power 2yx raised to the power of 3 plus 4x squared y raised to the power of 3. This will be equals to now. Is there any term that can be added together? No. So let us proceed. Minus 3x squared y raised to the power of 2 minus 4x raised to the power of 2 y raised to the power of 3 minus 2x y raised to the power of 4 minus 6x plus 13. Okay. Now to get the value of dy dx, I'm going to divide both sides by 2yx raised to the power of 3 plus 4x squared y cubed. Do you understand? So for this, I'm going to have dy all over dx is equals to negative 3x squared y squared minus 4x squared y cubed minus 2xy raised to the power of 4 minus 6x plus 13. All this all over 2yx raised to the power of 3 plus 4x squared y cubed. Do you understand? Okay, so you can see that it is easy to differentiate an implicit function. The first thing to note is that you first have to identify what you are differentiating and also what you are differentiating with respect to. Are you getting it? In this case, we are differentiating y with respect to x. So anytime I differentiate y in this function, I'm going to multiply that derivative by dy over dx. Okay, so let's look at this question that we have on the board. We are asked to find the derivative of y with respect to x. Looking at this question, it is easy to make y the subject of the formula, and then we are going to expand and differentiate. Is that not it? So that's the way I'm going to go. Here, I'm going to have y equals to x raised to the power of 3 multiplied by x minus 4. Are you getting it? Now expand. X raised to the power of 4 minus 4x raised to the power of 3. Okay? dy all over dx will be equals to 4x raised to the power of 3 minus 12x raised to the power of 2, which is the final answer. Do you understand? You can see that taking the derivative of a function is quite easy. So I hope you've learned one or two things in this class. If you want to learn more on implicit differentiation, you can check the link in the description of this class, and also you can check the playlist on this channel, Differential Calculus. I've done so many examples. Are you getting what I'm trying to say? So that will be all for this class. If you have any question, let me know in the comment section. See you in the next class.